All right, let me start with the first question. Based on my grading at this point, many students, actually most of you missed this question. Only a very small number of students got this one. The answer C, 8. Yeah. So here, oh yeah, let me change the color of my pen. Blue color. All right. Look at each term. The exponent is multiple of 3. Yeah. Here, I may like to use a new variable y for that x cubed. Okay. Yeah. So then we can write this p function, p of y, yeah, equals a0 plus a1y plus a2y squared. Oh, a chat message. Let me look at the chat message. Oh. All right. Assignment marks. Oh, assignment marks were not released.
Yeah.
What's that? Can you explain a little bit? Pavan? Homework number 1. Homework number 1. I didn't post the answer, but yeah, I will post after this meeting. Yeah. Any question? Any question? All right. Yeah. Assignment marks. Let me see. Yeah. If you give a little more information, I can understand better. Yeah. All right. Let me just, continue. Yeah. All right. Then this polynomial, let me just use ... okay? Because you know the meaning. Right. Someone, can you turn off your microphone? Yeah. All right. Yeah. Thank you. Sorry. Someone check your microphone. Yeah. Let me check myself. Alan, William, Alan, your microphone. William, yeah. William, Alan. All right. Okay. All right. Okay. Yeah. So let's continue. Yeah. All right. From here, by the honors rule, we know we need 6 multiplications. All right. Yeah. But some students count 5. Yeah. So they wrote the factorization expression correctly, but I noticed more than one students count this number 5, but actually 6. So that's the first mistake, some students. Second, to find y equals x cubed, we needed 2 multiplications. Okay? 2 multiplications. All right. So the total 6 plus 2, we get 8. Okay. Yeah. So that's this question. Yeah. But large number of students give me 7. Okay. That's the, biggest group. Then small number A and D. Yeah. So you can double check. Yeah. A few steps, either Horner's rule step or x cubed step. Yeah. So some students may count wrong at a Horner's rule step. Some students may count wrong at x cubed step. Okay. All right. The second one, also large number of students missed this one. The answer is 3. Yeah. So here the structure, the coefficients is very special. 14641, that corresponds to Pascal's triangle. All right, yeah. We practice Pascal's triangle many times. Yeah. So if you can recognize the Pascal's triangle structure, you can write it as 2 to the 4th, this expression. Yeah. If you get this step, then remaining part will be pretty easy. Okay, yeah. Repeated squaring, right? Look at that, yeah. Square times square, okay? All right. When you do counting, 1 multiplication for x squared, all right. Then another multiplication for, parenthesis, 1 plus x squared, parenthesis square. Then the third one here, okay? So the total 3 multiplications. Now, so this one, you need to be familiar with Pascal's triangle structure and also repeated squaring technique. These two combined, then you will get correct answer. From the first 2 questions, you can see you need to be familiar with a few important techniques we studied in this class. Yeah. And actually, we spent quite some time studying these techniques. Okay, yeah. Definitely, you can expect similar questions in our midterm exam. Okay, yeah. All right, so that's the first 2 questions. The next one, also, it's a big miss. Yeah, large number. This question, I give you hint. Yeah, in the hint, I give you the direction. Look at the limit. Okay, a to the nth over n to the dth. Okay, yeah. Here, a greater than 1, and thus d greater than 0. Yeah. And this limit, we did it in class, equals infinity. Okay, yeah. But those students still do this by intuition. Still, yeah, because based on my impression, most of the students missed this question. Now, only a small number of students got this one, okay, by intuition. The reason is, even if they know this formula, okay, this limit, they know it, but they do not feel confident. Even this formula is 100% correct, but they do not feel confident. Okay, still their intuition dominates. Okay, dominates. So at the end, when they put the answer there, still they select the one based on their intuition. Yeah. So that phenomenon is pretty common. Okay, pretty common. Yeah. Because even you have strong evidence showing you the first one is larger. The first one is larger, but you couldn't believe it. How can you believe it? 1.0, how many zeros after 1? 6 zeros, right? Yeah. And then add just 1 after it. This number is so close to 1, then those people probably just rounded down to 1. All right. Yeah. Because that fractional part is so small, most people just rounded down to 1 to the nth, that's 1, right? Or slightly larger than 1. How can you compete with n to the 1 millionth power, right? That's the intuition. But math, science, this kind of small error, yeah, we can treat this part small error. This is small error. Can be accumulated, can be built up to become a large number, huge number. All right. To convince you, I did some calculation, yeah, because we want to see, can you give me some concrete n? And for this concrete n, A is greater than B, right? Yeah, because you want to see concrete example. Yeah. Before this session, I just did it, with the help of computation software. Yeah, let me show you the result, my computation result. I find that n number when n equals 10 to the 15th power. How about that? This is a big number, right? Yeah, but still not scary, right? 10 to the 15th. You pack 15 zeros after 1. This number would make A option greater than B option. Let me show you quickly. Not too difficult. Yeah. A option, let's do B option first. Okay. So the B option, m to the 1 millionth power, simply 10 to the 15 millionth power, right? Yeah. So this expression is very easy. Yeah. So let us put this aside and do calculation on A option and see if we can get a larger expression. All right. A side, I need to use the Wolfram alpha. I talked about that last time. Okay. Yeah. Wolfram alpha. Right? Yeah. Yeah. So there is a friendly user interface. Yeah. So I click math input button so I can enter, exponential expression. Yeah. After I enter, this expression, that 1.0060, then 1 to the 10 to the 15th. How about that? All right. Then it gives me approximate expression, not the final answer yet. All right. 10 to the 10 to the 7.63 something. All right. All right. Then it does not give me the final answer, but it gave me a message. I need to pay to get premium service to get a relatively more complicated computing results. I don't want to pay that premium service. All right. Yeah. So then for this one, it's easy for me to get a final answer, right? Because I can calculate this exponent number easily. All right. Yeah. So I still use the Wolfram alpha to calculate that number. So I get it's greater than 10 to the 7.6, right? So I drop that 3.3 something after digit 6. All right. Then I evaluate that 10 to the 7.6, the exponent number. All right, so I get 10 to the 39 million. All right, 39 and the 6 zeros after 39. Is this greater than B option? Yeah, definitely it's greater than B option. All right, so here I hope with this example you're convinced when n equals 10 to the 15th power, then A greater than B. Yeah. All right, so let me look at the message. Yeah, let me make my message window slightly larger. All right. Can we say since A, yeah, yes, you can, yes. Cameron, yeah, correct. Let me complete your sentence. All right. Can we say since A is an exponential function and B is a power function, A will increase? Good, perfect. Yeah, your answer is perfect. All right, Cameron, that your answer is perfect, good enough. Why I spend so much time? Because the reason is when I do grading, I estimate 80% of the students select the B. 80%. I didn't do statistics, but my impression, all right, my rough impression, 80% students select the B. I believe among those 80% students, some of them know the fact you just pointed out. Okay, yeah. Exponential function increases much faster than power function, polynomial, whatever. All right. Yeah. But for those students, they select the B. So that I just guess what's the reason behind it. This I try to explain this phenomenon. Okay. The phenomena, I guess, because their intuition dominates their decision. When they make the final decisions, if they select the B, they will feel very comfortable in their psychology, very comfortable. If they select A, even the mathematical analysis tells us A is the correct answer, but they do not feel that answer is correct. All right. So here I spend a lot of time. I do concrete calculation. So I plug in numbers, n equals 10 to the 15th power. And let you know, A is really greater than B in the number expressions on paper. How about that? All right. Think about that. All right. Yeah. Yeah. So that's an interesting phenomenon. All right. Yeah, because as an educator, it's important for me. I have been teaching this class for more than 10 years, 10 something years. I gave this question again and again, but every semester, the same result. Approximately 80% of the students select the B, not A. Okay, yeah. No matter how much hint I give them, I cannot tell them the answer, right? I cannot A is the correct answer. I couldn't say that sentence. But at the end, 80% of them pick B. Okay. All right. Yeah. So let's move to the next one. Yeah, because we have large number of questions. I hope I complete all the questions today. Yeah. All right. So number 4 is fine. Yeah. Although it's not perfect, small number of students missed number 4, but I do not need to explain. Okay. Yeah. Because we did similar questions in our quizzes. Yeah. Number 5, another big miss. So let me do the calculation another time. But here, I do not need to use computer software. I do not need it. It's not as hard as question number 3. So we do not need a Wolfram alpha here. All right. Let's do computation A. Another 80%. Yeah, here, actually, this one more than 80%. Give me the answer A, not B. Still by intuition. Yeah. All right. So for A, that expression is easy, right? Yeah. Because N equals that 10 to the 10 to the 10. All right. Just, you know, we only take the exponent part. Because the log base and exponent base the same, let's just take the exponent number directly, 10 to the 10. How about that? All right. B, not too hard, yeah. But based on my, you know, observation, so many students couldn't do B. Yeah, they can do A. Yeah. They can get this number easily. Yeah. But most of them couldn't get a B expression. You know, that's surprising. Yeah. So let me show you. Yeah, the B, 10 to the 10 to the 10. All right, the whole thing raised to 0.0000001. All right. Yeah. This one, yeah, whatever it is, just some number, right? Yeah. By the algebra property for exponential function, yeah, we have this. Exponent number, we treat it as a whole number, okay? Multiply that external exponent number. That's the algebra property tells us. All right, yeah. But this step, yeah, many of you couldn't get this step right. Yeah. Later, I'll show you one typical error. Yeah, one student showed me. All right. All right. Then equals 10 to the 10th multiply 10 to the negative 6th, right? Yeah. We can write the 0 point something as the, you know, exponential form with negative exponent number. That's 10 to the negative 6th. Then 10 and minus 6, we combine, we get 10 to the 10 to the 4th. How about that? 10 minus 6, that's 4. Okay? All right. The last expression, 10 to the 4 zeros, right? 10,000. The exponent number is 10,000. The exponent number comparing the A case 10. Compare 10 and 10,000. Which one is larger? Look at that. It's obvious, right? Yeah, it's obvious. Yeah. But most people got it wrong in this step. This step, yeah, most students got it wrong. Why? One student showed me. Still, that student used the Wolfram Alpha, and that student include screenshot. Yeah. So let me show the screenshot to me. You know, provide the evidence. But that screenshot, I carefully checked the formula entered. I found a critical mistake in the expression. So that is that student didn't use this expression. Let me show what that student used this expression. 10 to the 10 to the 10 to the 0.0000001. How about that? Put that, combined with that top exponent number 10. Then it is much smaller. It would be much smaller, all right? Yeah, that student did this way. But actually, fortunately, that student got the answer correct. Yeah, that student got the answer correct. Yeah, slightly, that student told me based on this is a wrong interpretation, okay? But fortunately, this one still gives B greater than A, okay? Slightly greater, yeah. So then that student, very happy, told me just this is the point, the second expression just overtake the first expression at that point. But actually, we know it's not that critical point. Yeah. Anyway, yeah, that's the whole story. All right. Yeah. But these two questions, you missed a lot. Yeah. So in the midterm, I will give you similar questions. Yeah. Because I really want you to understand the whole procedure. Yeah. All right. The next question, next two questions, another big miss. Number 6, number 7. Yeah. I gave partial information, hint, yeah. But for C and for number 6 and number 7. Number 6 a little better, yeah. But number 7, still many students select B option, not A. Yeah. Still, this very small exponent number gave them some illusion. Yeah, gave them some illusion. Yeah, so they feel B expression is extremely small, so it cannot compete with A expression. Yeah. But we know even that is extremely small. Look at the limit. Log n over n to the dth power. The d is positive. Okay. It could be very small, but if only it is positive, we know this limit is 0. So in the long run, A expression cannot compete with B expression. Ratio approaches to 0 when n approaches to infinity. Yeah. This one I don't. So I didn't, plug in numbers. Yeah. So because after we did so many similar questions, we should be confident that A should be smaller than B in the long run. Okay. All right. But for the question number 6, some students confused with ACD. Yeah, actually, also some students select ACD. All right, yeah, some A, some D, yeah, not a C. Yeah. All right. Log of M, to see that, log of M, we know it cannot compete with, so, all right, so for any n to the dth power function with positive exponent, it is less than that where n is sufficiently large. Okay, all right, so we know that. But in order to compare in a convenient way, yeah, because although we know this fact, but when we do comparison, we still feel not quite convenient for the comparison. All right, yeah. So here, in my thinking, yeah, so my own understanding, yeah, I like to use log expression approximately n to the epsilon exponent. This epsilon, let us imagine this epsilon is quite magic. Yeah, we know epsilon delta in calculus, right? Yeah, what is the epsilon? There is special meaning for epsilon in calculus, right? When we define limits, define derivatives, continuous functions. Yeah, some students learned that epsilon delta definition, but many of you I know, your instructors skip that part because that part too abstract. All right. So here I borrow that epsilon. Yeah. This epsilon, first, this epsilon is positive. It's greater than 0. Yeah. We do not allow this epsilon to be 0 here. Yeah, what I mean here. Because if it's 0, then it becomes 1. So then that's not right to represent log of n, right? Yeah. So we must make epsilon greater than 0. But at the same time, this epsilon must be less than d. Yeah, that d for any positive d. Positive d. Okay? Yeah. We need epsilon has that property. In that way, we can use n to the epsilon power to approximate log of n. If we use that, then C option becomes n over n to the epsilon power. How about that? It's much easier to handle, right? Because log is gone. For most people, log is not very friendly in our algebra simplification, right? So we want to, make the whole expression as easy as possible. So here, if we use this expression, you will see n to the 1 minus epsilon. How about that? Okay, all right. Then let's look at the expression. We look at the dominant term. That's n, right? All right. A expression, we look at the dominant term, skip the minor terms, also n, right? N to the first power. Here also first power. 1 minus epsilon. We know epsilon must be positive number, right? Yeah. We do not allow it to be 0. It must be positive. So it is less than 1, right? So C option, the growth order is 1 minus epsilon. So that is the smallest than all other options. Yeah. This is my own understanding. I based on my own experience. So I borrowed that epsilon language. If you feel, yeah, because you need to get used to that special epsilon. That epsilon is so special. Yeah. If you feel okay with that epsilon special property, then you can use this way to help you make the log involved expressions as easy as possible. Okay, yeah. All right, yeah. So I hope, yeah, this part pretty abstract, yeah, but this part is the foundation of the algorithms. Because think about all these questions, yeah, this second half, yeah, starting from question number 3, yeah, excluding question number 4, okay? All these questions, that's the fundamental things in algorithms. Because when you compare different algorithms, which one faster, which one slower, basically you need to have idea for different growth function expressions, which one faster, which one slower. You need to have that sense first. Then you can do comparison on different algorithms. So that's the reason this part is very important. Yeah, and I will test this part, another chance for you in the midterm test. Yeah, I want to make sure you have good understanding on this part. Yeah. All right, so let's move to the next page. Yeah, but I need to do a little faster. Yeah, I hope I can complete it. Yeah. Within our time limit. Yeah. Question number 8. That's pretty good. Yeah, almost all of you got this one. Yeah. But the question is, can you, when you answer this question, can you have some example in your mind? Can you write a specific concrete example to, that reflects this property? Yeah. So here, suppose, all right. Suppose, let's assume x1 less than x2 less than xn. Okay. All right. Then can you write a special arrangement, a special sequence of these elements so that none of them is in place? Now, because the in place means this order. Now, so each element is not in its correct position. Okay, all right. That should be pretty easy, right? Can we do a shift? Yeah, we can do position shift. How about that? Okay, clockwise, counterclockwise, both fine, right? How about this? X2, X3, xn, x1, right? Yeah. This one, none of them is in place, right? None of them is in place. Yeah. Yeah. So I hope you can, in your mind, you can come up with some good examples. Yeah. It's not easy to find appropriate examples, not easy. Yeah. But without example, probably you just make your guess. You believe it is correct, right? You believe it is correct. But if I ask you why it is correct, can you convince me it is correct? If you do not have this example, then it may not be very easy for you to convince me it is correct, right? Yeah. Think about if I give you an oral test. Sometimes, there is kind of oral test. Can you explain the reason behind it? Right? Yeah. All right. I try to save time. All right. The next one, D. Yeah, let me do it quickly. Yeah. Why so many students give me C? Yeah. I saw one student plug in. Yeah, that's fine. I saw one student plug in the phi number. We know the phi number, right? Yeah. So that student used some calculator to calculate expression for x to the 5th, and then plugging into the 4 options A, B, C, D, and at the end, D is closest to x phi to the 5th. Yeah, I saw that. It's okay. Yeah, it's legal. Yeah, for me it's legal. Although I like to see you doing the algebra to get that conclusion, but you can use any legal means to get the correct answer. Yeah, that's fine. All right. Here, equals, yeah, we know phi times 1 plus phi square, right? Why 1 plus phi square? Because 1 plus phi equals phi square, right? Yeah. Phi square square, so 1 plus phi square, okay? Phi 1 plus 2 phi plus phi square, right? Okay, all right. Replace phi square by another 1 plus phi. 1 plus phi. Okay? Yeah. Phi 1 plus 2 phi plus 1. All right. So let us combine them. Yeah. Oh, combine them. Yeah. 2 plus 3 phi. How about that? 2 plus 3 phi. How about that? Okay. All right. 2 phi plus 3 phi squared. Okay. Yeah. Phi plus 3 times 1 plus phi. How about that? Every time when we see phi square, we replace it by 1 plus phi. Right? 3 plus 5 phi. How about that? That's our D option. That's our D option. Okay? Yeah. This is the right path I like you to take. Okay? I like you to take. But for most of you, it may not be easy. I like you to go this direction, but I have to admit, for most of you, it is not easy. Yeah. All right. Then number 10, many of you did much better in this one than number 9. Yeah. Many of you did much better. So here, let me use 2 minutes to do it for those students who cannot do the similar algebra here. Plus 1. All right. First, we do simplification on the denominator expression. There are different ways. Here, I just use one way. Replace phi squared by 1 plus phi. Plus 1. Okay? Then, simplification, phi squared plus phi plus 1, replace phi squared by another phi plus 1. 2 cancellation. Yeah. So 1 over phi plus 1. Okay. All right. 1 over phi plus 1. Yeah. 2 terms. Denominator 2 terms. Not friendly for cancellation, right? Not friendly for cancellation. Okay, not friendly for cancellation. I like to have a one-term expression. So 1 over phi squared. I replace phi plus 1 to phi squared again. Now the cancellation is easy. I replace 1 by what? Okay, yeah. All right. Because phi squared equals 1 plus phi. That. So 1 equals phi squared minus phi. Okay, yeah. So we replace 1 by phi squared minus phi over phi squared equals 1 minus 1 over phi. Okay. Then for this one, another phi squared minus phi over phi, we can do cancellation. Okay. After cancellation, simplification 2 minus phi. How about that? Okay. Yeah. So you can see for these two questions, number 9, number 10, yeah, you need to have some good algebra skills. Yeah, so I like you to have this kind of formula transformation basic skills, yeah, for this class. Yeah. Otherwise, yeah, you cannot go too far. Many times we need to do this kind of calculation. Yeah. And some students even argue, how can that be possible, right? Phi q plus 1 at the denominator, how can you eliminate that denominator? Right? Yeah, but yes, we can, because here it is golden ratio. Phi is golden ratio, that it's possible. We do not mean for arbitrary expression we can do that kind of simplification. But golden ratio is, really special number. A lot of, interesting properties. Yeah. All right, so let me move to the next. Yeah, I like some students check the microphone, yeah, because a lot of noise. Yeah. All right, next. Oh, yeah, let me just quickly. Yeah. All right, so these next 4 questions, most of you got them easily. Yeah. Number 12, some students miss number 12. Yeah. Yeah. Let me, yeah, so here, the maximum number. Okay. Maximum number if there are n elements. Because later we need to use this result. Later in our question number 24, we need to use this results. So let me just write that expression here first. All right. Maximum, because we know any 2 pair of elements, there is inversion. That's the maximum. Okay. Yeah. So the number is 1 plus 2 plus ... plus n minus 1, not n. Yeah, some students give me the n. Yeah, n minus 1. So that is 1/2 n times n minus 1. Okay, all right. Then this formula, yeah, we will use it in our question number 24. We need to use this formula another time. Okay, all right. Then number 13, minimum at k is 2, not 1. K cannot be 1. In my hint, I actually I explained if k is 1, we can get contradiction. K is 1, that means the remaining n minus 1 elements are in place. Okay. Other than that one element, the remaining n minus 1 are in place. Okay. Yeah. Then if we already have n minus 1 elements in place, there's only one position left for the last element. Then that element has no choice. That element has to go to its right position. That's in place. All right, that's in place. Then you will get all elements are in place. That's not k equals 1, that's k equals 0. Okay, so here, when you assume, if you assume k equals 1, but you will get some contradiction because you will get k equals 0. Okay, so that's impossible. All right, then you need to see if 2 is possible, because we know 2 may not be possible, right? Yeah, but why 2 is possible, we can see that easily. Still use some special example to see it. Okay, the special example, let us consider x1 less than x2, that case, okay? So this order in place, all right, in ascending order. Let us swap just two adjacent elements. How about that? Let us consider x2, x1, swap first two elements. Then x3, x4 through the last element. You can see after the swap, the first two elements are not in place, and all the remaining elements are in place. That means it is possible. Answer 2 is possible. So we can take it. Now, because I noticed one student showed me 2 is not possible. So then that student gave me 3 as the answer. But here you can see if you can construct an appropriate example here, you know, you can get a better answer. Your answer is 2, not 3. Okay? Yeah, because you construct this, you know, simple example. Okay? Yeah. All right. Let me continue. Yeah, I only have a little more than 15 minutes. Yeah, so that's hard for me to. Yeah. Let me just skip relatively easy questions. All right. Yeah. Focus on relatively hard questions. Yeah. All right. And so I can save some time. Yeah. Yeah. Okay. All right. Oh, good. Yeah. Many questions I can skip. Yeah. All right. So here, let me spend the remaining 15 minutes only on those hard questions. Yeah. Okay. Yeah. So that's the last page. That's the hard questions. Okay. All right. Last question. Yeah. Actually, I just explained these 3 questions, each one 5 minutes. All right. The last one, you just look at my solution. Okay. Yeah. Yeah. Look at my solution. It should be, you know, good enough for you. All right. So last 3 questions. The next 3 questions. Answer number 20. Question number 22. Answer is 5. In my hint, actually, I already point you, lead you pretty much already to the destination. Only just the last jump on your path, you will get there. Yeah. In my hint, I told you because x3 is the median and its position known. Yeah. Median means its position is known. Okay. Yeah. Its position is known. Let us put it aside. How about that? Okay. Because we don't worry about it. It is completely known, right? Let's take it out of the consideration. That's our elimination method, right? Take it out of the elimination method. All right. Then that means we only need to sort 4-element array. Okay, 4-element array. Then I also point you to our notes in the insertion sort that, you know, part A of module 4, insertion sort, the last topic, you can see the solution. That is 5 comparisons. Okay, 5. All right. So now you arrange, yeah, after 5 comparisons, you get x1, x2, x4, x5, okay, sort it in ascending order, okay? Then final step, because x3 is its location is known, you just put it back in its right position in the middle without any comparison, right? You put x3 back, you do not need one more comparison, right? Yeah, known position. Yeah. So yeah, many students gave me 6 comparisons, the answer. Some give me 4, but if you give me 4, so your answer may not be correct. Yeah. Look at that. You carefully check if your 4 comparison answer is correct or not. Yeah. Yeah. Because if your 4 answer is correct, that means you can use 4 comparison to sort 4 element array. And we know it's impossible, right? Yeah. We know it because to sort 4 element array, there is a lower bound, log base 4 factorial floor function. This is the lower bound. Okay. This lower bound equals 5. How can you use 4 comparisons to sort 4 element array, right? Yeah, you cannot. Yeah. All right, so that's question number 22. Question number 23. Yeah. Let me show you this way. Yeah. Pretty simple. If you take this view, then it will be much simpler. Yeah. All right. Many students gave me the answer, quite different. Yeah, the answer 109. Yeah, let me show you why the 109 answer. Okay. All right, so let us put these elements in these positions. Okay, yeah, All right. The last position, 114. Okay, 113. All right. 112, all right, yeah. 111, all right. Another one, 110. Yeah. Because these positions are important in my discussion. So I need to, write them out. Yeah. All right. I saw one student took this view. Yeah. So the proof is pretty neat. Yeah. All right. When you have this view, let us consider the first 110 elements. Okay, let us do not look at the last 4 elements. Only look at the first 110 elements. Okay, yeah. In this subarray, to find a maximum, okay, we need 109 comparisons, right? N minus 1. Right? That means this max element beats all the remaining 109 elements in this subarray. Right? Yeah. Those 109 elements cannot compete with this max element. All right? Yeah. All right. Then let us put this max join with the last 4 elements. Is this max among the top 5? Yeah, the total 5. Okay. Total 5. Can we say it's among top 5? Yeah. Because max, we're not sure it is the largest or smallest in these 5, but whatever position it takes in these 5 elements, it's among the top 5. Okay, It is among top 5. Look at this view. This is the simplest way to find the answer. Okay, yeah, use this way. Still elimination method. This way, still based on the elimination method. Okay, yeah. So here you can see in this class, how important is this elimination method? All right? Okay, yeah. Finally, the last question. Yeah, this is probably the hardest. Yeah, based on my grading, only one student got this question correct. The answer 2n minus 3. Yeah. Some students did experiments. Yeah, but your experiments may not be enough. Yeah, based on what I have seen on your scratch paper. Yeah, on your work. Yeah. I look at your work. I notice you just got partial information, still not sufficient. Yeah, you need to do a little more examination. Yeah, then you can get correct one. Yeah, so that's some students gave me partial answer. Yeah, a few students gave me n minus 1. Yeah, that's part of the step, not sufficient. Yeah. So here, let me show you how to get. Remember, we need to use the, the maximum number of inversion for an array, never inversion for an array. This result we know from, one of our previous question is this. Okay. Yeah. Here I do not use the, use that 1/2 n, because this expression will be easier for us to get a final answer. Yeah. All right. So let us use this summation expression. All right. Now, constructing appropriate example is useful for this question. Yeah, remember, in our previous 2 questions, we need to construct appropriate examples. This one, we need to construct 2 appropriate. Well, yeah, just one example. Yeah. All right. Here, let us assume this is the, correct order of the array. Okay, correct order of the array. Yeah. We want to have the largest number of inversions, right? Yeah, that should be that maximum, that max case corresponds to x and, the reverse order. Okay, and the number of inversions is this expression. All right. Okay. Now, I do one swap on this max expression. I just do one swap. Okay. Which one? The first and the last. First element, last element. I do one swap. Okay. Yeah, based on our question requirement. That is the swap. But after that swap, we will have x1, xn minus 1, dot, 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 x2, xn, right? That's the new arrangement of these n elements. Now, if you look at the inversions, after one swap, how many inversions do you have? Yeah, look at that. Okay, yeah. The first element is in place. The last element is in place, right? In place, can we exclude them from the consideration? Already in place. Okay, And they are in place, but first one, last one. So they will not contribute any inversions. Yeah. So I need to say another thing. Yeah. These two elements, these two, yeah. Let me look up my, I have 3 minutes. Yeah. X1 and Xn, yeah, here, okay, would not contribute to the number of inversions, right? Okay, so we can ignore these two elements. Then look at the remaining elements. How many remaining elements? Okay, n minus 2 elements, right? After we exclude the first and the last element, there are n minus 2 remaining elements. And these n minus 2 elements are arranged in reverse order, right? Descending order. Descending order, then the number of inversions is 1 plus 2 dot 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 plus n minus 3, right? Yep. The total number of elements minus 1. So the last term is n minus 3. Then compare with the previous one, 1 plus 2 plus dot 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 plus n minus 3, n minus 2, sorry, n minus 2, and plus n minus 1, right? Then you do subtraction, the bottom line minus the top line, subtraction, will you get n minus 2 plus n minus 1? Right? All the other terms are canceled out. Only the last two terms left. N minus 2 term, n minus 1 term left. That is 2n minus 3. That is 2n minus 3. That is our final answer. Okay? Yeah. That's the way we find the answer. Relatively hard, but a little challenging. Yeah. You need to really do some good work to find the correct answer. Yeah. All right. I run out of time. I have to stop right here. Yeah. If you